Hello, we are Team 28 and our capstone project was building a minimal NPU in VHDL and ADA. The team members are Jacob Lukes, Dipen Rathod and Dylan Stock. I am Dipen and I will be presenting a brief overview of the project. We'll start discussing the system features. First up is the NEORV32 and the Wishbone bus. The NEORV32 uses a 72 MHz clock. It has 128 kilobytes of instruction memory, which is used to hold user programs. It also has 128 kilobytes of data memory, which is fast processor local RAM used for storing runtime data, stack, and variables. The Wishbone bus has a 32-bit data bus width, a 32-bit address bus width, and a handshake protocol with acknowledgement, which allows for reliable transfers. Here are the NPU features. The NPU uses the NEORV32's clock, therefore it operates at 72 MHz. It has 4 tensors. Input tensor stores a 10 KB input tensor which stores the inputs of the operation, a 36 kilobytes weight tensor which stores the weights required for an operation, a 2 kilobyte bias tensor which stores the biases required for an operation, and a 10 kilobytes output tensor which holds the output of an operation. The NPU supports the int8 format for storage and computations. Larger precision numbers are used in intermediate results as necessary. Each int8 byte is stored in a 32-bit word in the tensors to make the best use of the Wishbone's bus width. This design choice supports transferring and unpacking 4 int8 elements at a time. It supports the following operations. In activation functions, it supports ReLU, sigmoid, and softmax. In pooling functions, it supports 2x2 max pooling and 2x2 average pooling. It supports full dense layer computations. Lastly, it supports multiple input and output channel convolution. Here are the camera controller features. The camera controller uses the NEORV32's clock as well, therefore it also operates at 72 MHz. It is designed to interface with the OmniVision OB5640 camera. It supports capturing grayscale image data from a YUV422 data stream at a rate of 10 frames per second. It has a built-in SCCB programmer which programs the camera with default settings on bootup and allows a developer to reprogram the registers in application code. Lastly, it has a 10 kilobyte image buffer, allowing the controller to store a 100 by 100 grayscale image. Now, we'll discuss the worst case NPU performance. We compare ADA measurements with VHDL test bench measurements of the wishbone NPU peripheral. The test bench is closer to direct hardware timings, while the ADA results also include software register accesses and busy polling. These settings used for performance measurements fill or nearly fill the relevant on-chip tensors, so they represent worst-case layer timing. First, we'll discuss the activation function performance. ReLU, Sigmoid, and Softmax use the full activation tensor. Softmax could not be tested using the test bench because it requires logic defined in the library function. There is very little overhead added to the NPU's raw performance by the ADA application layer. Here we show the worst case NPU performance for the pooling functions. Pooling uses a 100 by 100 tensor. Again, there is very little overhead added to the NPU's raw performance by the ADA application layer. Lastly, here we show the worst case NPU performance for the dense and convolution layer. Dense uses 18 inputs and 2000 output neurons, and convolution 2D uses 13 by 13 tensors with 50 input channels and 80 output channels. Overall, uh, the differences are small, ranging from less than 1 microsecond for ReLU to about 6.4 microseconds for Sigmoid, which indicates that most of the measured gap comes from the software and communication overhead between the CPU and the peripheral. Now, please watch the system demo where we classify hand gestures as rock, paper, or scissors in real time. Thank you. So, welcome to the final integration test demo. So, we aim to detect rock, paper, scissors using hand gestures. So, the 0 is for rock, 1 is for paper, and 2 is for scissors. A warning, the camera captures images in a small window, so sometimes it may make wrong predictions, but you'll see. So now my window is it's just 2 for scissors, yeah, paper, scissors, rock, paper, scissors, rock, paper, scissors, paper, rock. Thank you.